One of the handy skills that we must have when we study physics is the ability to do what we call dimensional analysis. So, whenever you work out equations, the units that you end up with should be correct for the thing that you are looking for. For example, if you have an equation F equals to ma, to obtain F in Newton, you should have the mass in kilogram and the acceleration in meters per second squared. Dimensional analysis is a technique to check if an equation is correct. So, if you have an equation, this equation will be valid if both sides have the same units. Dimensions as length, mass, time, or combinations can be treated as algebraic quantities. So we can add, subtract, multiply, or divide those dimensions. Both sides of equation must have the same dimension. So if we have an equation as F equals to ma, we should have Newton at the left and Newton at the right to have a good equation. Any relationship can be correct only if the dimension on both sides of the equation are the same. We cannot give numerical factors. This is the limitation of dimensional analysis. We will give now some example to explain how we do the dimensional analysis in practical. Dimensions has a specific meaning. It denotes the physical nature of a quantity. Dimensions are often denoted with square brackets. So when we speak about length, it's denoted L between brackets. Mass, it's M, and time, it's T. So the dimension of length, mass, and time are L, M, and T. We don't give any unit for a dimension. So when you speak about length, dimension of length is L. Each dimension can have many actual units. So L could have meter, feet as a unit. For example, speed, its dimension of speed is L over t. It's a distance divided by time. So it's a length divided by time. So it's L over t as dimension. In the SI unit, the unit of speed is meter per second. In the US units, it is feet per second. For the volume, dimension of a volume is L cubed. In the SI units is meter cubed, and in the US units is feet to power 3. So dimensions of a length, it's L, but it could have many different units. So given the equation, x equals to half a t squared, a for acceleration and t for time. So to check if we have the check dimension on each side, so the dimension of x position is L, it's a length. The dimension of the acceleration is L over t squared, position divided by time squared. And t, it's time, so it's t squared. So t squared cancel, leaving L for the dimension of each side. So we have L equals to L. This equation is correct. There are no dimension for the constant, so we don't give any dimension for the constant half. So we now know that this equation x equals to half at squared is the correct equation. So you can try to find the exponents in the expression x proportional to a to power m times t to power n. So you have now this equation a to power m and t to power n. You should do a dimensional analysis to find the values of m and n. Another example. Suppose we are told that the acceleration of a particle, A, moving with uniform speed v in a circle of radius r is proportional to some power of r, say r to power n, and some power of v, say v to power m. Determine the values of n and m and write the simplest form of an equation for the acceleration. So we have a equals to k is a proportional constant, r to power n and v to power m. Now if you're doing dimensional analysis, the dimensions of acceleration is L over T squared. K is a proportional constant, so she don't have any dimension. R to power n, R dimension of R is L, R is a distance, so L to power n, and V is distance divided by time, so dimension of V is L over T to power m. So we have L over T squared equals to L to power n plus m divided by T to power m. If this equation is correct, so we should have the same units. So we should have n plus m equals to m. So the exponent of L should be the same. L to power 1 equals to L to power n plus m. So 1 equals to n plus m. And the exponent of t should be also the same. So t squared, it's equal to t to power m. So m equals to 2. So if we have m equals to 2, so n must be equals to minus 1. So this equation is equal to k v to power 2 divided by r. K, the proportional constant, stay as an unknown. Using dimensional analysis, we don't have any information about